Okay, so the second half of lesson 2.6, we're looking at angle proofs. So really more of the same type of thing, except now we're focusing on angles. So example number 4 says to fill in the missing reasons. And we're given that KM bisects angle JKL. And we're trying to prove that the measure of angle MKL is 1/2 the measure of angle JKL. So first of all, our first statement says KM bisects angle JKL. So our reason for that, well, that was the information that was given to us. So from here, the next statement says the measure of angle JKM is equal to the measure of angle MKL. Well, if we look at our picture to help us to make sense of this, JKM is this one over here on the left, and they're telling us that it's equal to MKL, which is the one on the right. Well, the reason for that comes from this key vocabulary word right here, bisect. So this would be the definition of bisect, or if you put the definition of bisector or definition of angle bisector, those would be correct as well. Then our next statement says the measure of angle JKM plus the measure of angle MKL is equal to the measure of angle JKL. So if you look, those are the two smaller angles that are being added together to make the larger angle JKL. So if we're adding two smaller angles to equal a larger angle, that is our angle addition postulate. Then our next one says the measure of angle MKL plus the measure of angle MKL is equal to the measure of angle JKL. So we have two of them now instead of just one. Where did that come from? Well, if you look at this line up here, the second line, we said that these two were equal. So we just replaced the JKM with a second MKL. So anytime we're replacing something, that is substitution. And then from here, now we have 2 times the measure of angle MKL is equal to the measure of angle JKL. Well, didn't we just combine these two like terms? They're the same thing, so we can combine them. So this is just combine like terms. And the very last one says the measure of angle MKL is equal to 1/2 times the measure of angle JKL. Well, didn't we just divide both sides by 2 to get rid of it in front of this measure? So that would be our division property. Okay, and that is now the end of that proof. Let's go ahead and look at our last one here. So we want to once again fill in our missing reasons, and it says we're given that BD is perpendicular to BC. So if you think about it, we don't have a picture here, but we could draw one, right? So BD could be something like this. Right, so here's B and here's D up here, and it's perpendicular to BC, which is over here. And we're told that the angle ABD, so that has to be something like this, right? So A has to be over here somewhere kind of on the left. That angle is congruent to angle DBE, so DBE, which has to be somewhere kind of in between that angle there. So now we have a picture to kind of go along with what we're talking about, just so we can make sense of it as we're working along. And we're trying to prove the angle ABD and angle EBC are complementary. So our first statement says BD is perpendicular to BC and angle ABD is congruent to angle DBE. Well, that's just our given information. Now, our second statement says angle DBC is a right angle. Well, if you look at the statement above, isn't there a key vocabulary word right there, perpendicular? So that is due to the definition of perpendicular. So always look for those key vocabulary words. Usually they're going to be used in some of the following reasons. The next one, the measure of angle DBC is equal to 90. So once again, isn't right angle another key vocabulary word as well? And isn't a right angle equal to 90? So that reason is the definition of right angle. Then our next statement says the measure of angle DBE plus the measure of angle EBC. So that's this angle here plus this angle here is equal to the measure of angle DBC, which is that right angle that we have. Well, if we're adding two smaller angles and it's equal to a larger one, that is our angle addition postulate. Then our next one says the measure of angle DBE plus the measure of angle EBC is equal to 90. Well, the only thing that changed is now we don't have DBC, but we have a 90 there instead. Well, didn't we say up here that DBC was equal to 90? So really, didn't we just replace it down here? And anytime you replace something, isn't that just substitution? Then our next one says the measure of angle ABD is equal to the measure of angle DBE. So looking at that one, this one's actually coming from our congruent statement up here in our givens. So it's changing it from a congruence into an equal sign. So that is our definition of being congruent. Then our next one says the measure of angle ABC plus the measure of angle EBC is equal to 90. So on this one, we went ahead and replaced a couple of things. So this DBE here, we went ahead and replaced it with some of our other angle information. So this is our substitution again. And then the last one says that angle ABD and angle EBC are complementary. Well, isn't that what it means for them to both go ahead and equal 90 degrees? So this is definition of complementary.